Okay, here are your notes for section 11.2, even though I taught it on Monday. I'll try to keep the video short. I'm going to put a harder example there that you might see on your homework, but first, a little bit of review of SOHCAHTOA. You can copy this down if you didn't. It tells you the 3 trig ratios that have to be memorized, and I Googled it since some of y'all couldn't see my handwriting. But I'm going to work a couple of the homework problems as a review and then turn you loose. So here we go. Number 1, okay, first you have to have all 3 sides. So, you know, if you have the hypotenuse, you got to find the leg, and if you have the leg, you got to find the hypotenuse. So number 1, we have the hypotenuse, 13 squared minus 5 squared. And we've got to square root that. And I'm going to, like I said, that's going to be 12 because the square root of 144. So this missing side is 12. So sine, again, this is where we're looking from. Sine theta, very bad at thetas, is the opposite side divided by the hypotenuse. Cosine theta is the adjacent side over the hypotenuse, 12 over 13, and tangent theta is the opposite over adjacent. So that is 5 over 12. So that's number 1. Now the harder example that I'm going to do is number 5 because it requires, well, for one, let me show you the Pythagorean theorem on it. Get my numbers, 11 squared minus, forgot my numbers, 5 squared. All right, square root of 96 is not a perfect square. So I kind of alluded to this the other day, but you got to break down 96. Now, I'd already done it in my calculator, but I divided it by 2 until I couldn't. And so I came up with 5 2s. So if you divide it by 2 5 times, you'll come up with this. So 2 times 2 times 2 with an extra 3. So this is the prime factorization of 96. So I multiply all this together, I get 96. Long story short, I'm square rooting. So you got to find a perfect square. There's a perfect square, there's a perfect square. I'm going to work this one a little bit different. Here are your non-perfect squares. So they're going to stay inside the square root when you square root. And here are my perfect squares. I'm going to put them all together, but instead of calling that 16, well, I'll just call it 16. And so that is 16 times 6, and the square root of 16 is 4. So 96 breaks down to 4 squared 6. Now, we come back to the math. It gets a little more complicated again, and I'll show you why, but this is 4 squared 6. Sine, so here's theta. Sine's not going to be bad. Okay, sine theta will be 5 over 11. Okay? Actually, no, these aren't going to be that bad. Cosine theta, so the worst part, simplifying the square root on this problem. I was thinking we might have to rationalize, and rationalizing might happen. Maybe we have to rationalize on tangent. Anyway, cosine is going to be 4 square root 6 over 11. And I'm out of room for tangent. Let me do tangent. Tangent will be, yeah, here's where we'll have to rationalize. Tangent will be 5 over 4 square root 6. But here's the thing. If I were to show you that answer out of the book, 4 square root 6, or you cannot have a radical from Algebra 1, you cannot have a radical on the bottom. Make sure my answer is right. So this is mathematically correct. But because I have a radical on the bottom, I have to rationalize. And you did this in Algebra 1. It's not too complex. You might have a hard time doing it in May because it's May. But this is just 5 squared 6. This will end up being 4 times 6 because square root 6 times square root 6 is 6. And so we end up with a 24 on the bottom. So if I were to read this answer to you out of the book, this would be your tangent theta. And if you don't watch the video, we'll have to talk about it again when I come back on Thursday. because it does apply. Okay, so I'll do 2 more problems, shut it down. Most people seem to think that this was easy when I taught it on Monday. I'm going to do number 7 again. Instead of theta, they have A. And so tangent, they give us tangent, which is opposite over adjacent. And so we'll do Pythagorean theorem to find the hypotenuse. So that's 15 squared plus 8 squared this time. And we'll square root 289. I don't have that one memorized. And hypotenuse is 17. And so sine A is 8 over 17. Cosine A is 15 over 17. And tangent A is, well, we already did tangent. Okay, so, and we're only going to do sine, cosine, and tangent, 3 trig ratios. I know the book talks about 6, and there are 6. Just trying to save y'all some work. We're just going to do the 3. I might teach you the 6 later. Number 13, we talked about this, that if you're on a coordinate grid, your theta always starts at the origin, and your x is always your horizontal, your y is always your vertical one, and if you're on the coordinate grid with these ordered pairs, you're actually also always looking for the hypotenuse. And so Pythagorean theorem again. I do know 169 is 13. Whoops, what did I just do there? Okay, getting it back in line. I thought I paused the video and I didn't, but it'd be okay. Okay, anyway, this is 13. And so sine theta is 12 over 13. Cosine theta is 5 over 13. And tangent theta is 12 over 5. So, very quickly, that's SOHCAHTOA, that's sine, cosine, and tangent. That should get you started on all those problems on that page. And I will see you all again on Thursday. And I'll be taking a homework grade for this for people who would like to not make a 0. All right, see you on Thursday.